Hey, data analysis friends. Welcome to the second day of video content after doing Bonsai. I've got 4 problems to talk to you about, I think. 4 problems. These problems, the first problem is, well, actually, why don't we title it? So today is the fundamental counting principle. All right, so what is the fundamental counting principle? How am I going to use the fundamental counting principle to solve some problems? All right, that's what we're going to do today. So problem number 1, I went in for lunch at Panera the other day, and I had a choice of soup or salad. They had 3 different types of sandwiches. They were running a limited menu. They had ham, they had turkey, and they had salami. And then they had a couple desserts. They had those really good cinnamon rolls. They had one type of cookie, chocolate chip, right? So the question is, how many different lunches could I make if I selected one from this column, one from this column, and one from that column, right? So what we do is we draw a tree diagram to help us out with that, all right? So let's see how many different things we could do. So it's going to get kind of big, so we'll save some space. So I'm going to start off with either a soup or a salad. All right, so I'm going to go salad down here. All right, now next up, I could branch off in 3 directions. I could get a ham, a turkey, or a salami. Same here, I could get a ham, turkey, or salami. And then I could branch off in 2 directions from each of those. I could get a cinnamon roll or a cookie. I could get a cinnamon roll or a cookie. I could get a cinnamon roll or a cookie. Same down here, I could get a cinnamon roll or a cookie. I could get a cinnamon roll or a cookie. I could get a cinnamon roll or a cookie. I don't know which one I'd pick. They're all very good as far as desserts. So it looks like I could go soup with a ham and a cinnamon roll, soup, ham, cookie, soup, turkey, cinnamon roll, soup, turkey, cookie. I could go through all these options. And so what happens is I have the same number of options as this number of things written here. So I've got 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12. So there are 12 options for me to buy at Panera. Okay, I'm looking at 12 options here. Now, there's a really quick way to do this. Now, yes, I'm going to have you draw a couple tree diagrams in the homework. I think the first 2 problems have you draw a tree diagram. But the easier way to do this is the basics of the fundamental counting principle. And here it is. I have 2 things in column 1. This is really important. Really easy now. 3 things in column 2. 2 things in column 3. If I multiply all those together, 2 times 3 is 6, times 2 is 12. Pretty magical. I'm going to get exactly the same thing as I did when I drew this huge tree diagram. Again, I'm still going to have you draw a couple tree diagrams, but this is the easy way to check your work. That is the fundamental counting principle. Let's do another one. This is a review from yesterday, and I just put dots all over the paper from my marker, being a Sharpie type marker. So you got to deal with the dots. Let's go with, I have 6 paintings on my wall. All right, I'm going to arrange those 6 paintings. Now I can't fit one above the other, right? So my 6 paintings are just going to go left to right. They look like this. I got a really big wall in my living room. There's 6 paintings. I can arrange them. And when I have different guests come over, I mix and match. So I'll move this one over here just to see if they notice. And they say that that's not true. I'm just telling stories. So I got these 6 paintings, and I got to know how many different ways I can arrange them. All right. So arrangement. All right. How many different ways can I arrange those pictures? Well, how many pictures could I put in this first one? 6. Once I've put that first picture in that spot, I have 5 left. I could put 5 in the second spot. I could put 4 in the third spot because I've already chosen these two. There's 4 left, and then 3, 2, 1. If I multiply all those together from the fundamental counting principle, so yesterday's assignment on factorials comes from the fundamental counting principle, I could arrange them this many ways. Let's see if we can actually do this. 6 times 5 is 30. 30 times 4 is 120. 120 times 3 is 360. 360 times 2 is 720. There are 720 different ways I could arrange those 6 paintings on a wall. All right. So I've done a problem with a tree diagram. I've done a problem with paintings on the wall. This was a review from yesterday, but you're going to have a couple more of those on your homework for tonight. Let's keep working on the same page. Okay, I have a lock. All right, my lock has 4 dials on it. So I'm going to draw a little picture of my lock like this. All right, comes up into the other problem a little bit, but that's okay. So this is problem number 3 we're going to talk about. It's got 4 little dials on it. You know, it's got like a little dial here and all. There's all the numbers on there, 0 all the way down to 9. And I can spin this, right, between 0 and 9. And there are 4 of them, 0 to 9, 0 to 9, 0 to 9. Okay, so I've got 4 different spots there, 0 through 9. And I'm wondering how many different ways I can arrange these. Okay, how many different locker combinations could I come up with to set? How I do a problem like this is similar to the problem above, but it's more like the first problem we did. So how many different numbers could I put in this first column? Well, there's 0 to 9. How many numbers are 0 to 9? Let's see. 0, 1, 2, 3, 4, 5, 6, 7, 8, 9. 10 numbers, 0 to 9. So that means that in this first, I could put 10 numbers. In the second one, I could put 10 numbers. In the third one, 10 numbers. In the fourth one, 10 numbers. So how many different ways? 10,000 different ways I could arrange that lock. Now let's change the problem a little bit. Okay, so this was for a lock. Lock combinations. Let's change it to a new one now. Or what if I couldn't repeat? Or if no repeat? All right, so that was my answer. If I could repeat numbers, like I could have 0, 0, 0, 0, that was okay, or 2, 2, 2, 2. What if I couldn't repeat? Well, in the first one, I could put 10 numbers because I don't care about repeating, 0 through 9, there's 10 numbers. In the second one, I could put, oh, now this changes. I only have 9 numbers because I already used one in the first one, so then there's 9 numbers, and then there's 8 numbers, and then there's 6 numbers. So if I multiply all those together, oops, I'm sorry, 6. Mr. Manor, can you count down from 10 to 7? If I do that, that's going to equal some number. I don't know what it is. And you will get the answer for what if the numbers didn't repeat. So that is the third problem. I have one more to do with you. And then we will be finished. And you'll be able to go and practice the fundamental counting principle. The last one talks about a license plate. Let me slide down here. License plate. License plate. That word always looks weird to me. I always want to put a C there. I know it's an S. License plate in a certain state consists of 3 letters, 3 numbers. Okay, 3 letters and 3 numbers. And wondering how many different ways, how many different license plates you can make. Okay, so how many can I make? If I can't repeat, all right, so if I can't repeat letters or numbers, how many different license plates can I make if I can't repeat letters or numbers? All right, so it's going to look like this on a license plate. I'm going to have, I can't remember, the letters go first, the numbers go first. I don't think it matters. Well, it's not going to matter in our case. I can't remember my license plate. Well, whatever. Let's pretend the letters go first. So with letter, number. That's really bad. I can't remember which one goes first. All right, so with the letters, so this is different. How many letters are there that could go here? Well, A through Z, 26. Now, if I can't repeat, I've used up a letter here. So how many letters would be left here? 25 for that second spot. And then I've used up two letters, so 24 for the third spot. So there's this many different ways that I can organize just the letters. Now the numbers are 0 through 9. I can't repeat them, so I have 10 choices here on this first number, 9 on the second, 8 on the third. Because, excuse me, out of reach, I'm going to grab my calculator here and actually give you an answer. I have 10 numbers, and I got one that I used up, so I can't repeat it, and then 9 and then 8. So finally, my answer is 26 times 25 times 24. And actually, I can just slap this right under here. Times 10 times 9 times 8. And that should give me my answer, 112320. So 11232000. Put in some commas. 11,232,000 different ways I can make license plates in a given state. If you had 3 letters and 3 numbers, I think most states are 4 letters and 3 numbers or something like that. But the problem's done the same way. You just have a few more choices. All right, that is the fundamental counting principle and some practice with it. Go do your worksheet and you'll turn it in. Have a great day. Thanks.